Okay, today we're going to be looking at acceleration as a derivative of velocity with respect to time. So we know that acceleration is calculated by a change in velocity over a change in time. If that change in velocity and change in time is very, very small, then we can say that the acceleration is a derivative of velocity with respect to time. We call this the instantaneous acceleration, or just the acceleration of the object at any given moment in time. Now, if we have acceleration A as a derivative of dv by dt, we know from previously that v is the derivative of displacement by with respect to time. So we can also think of acceleration as the secondary derivative of displacement with respect to time. So let's look at a couple of examples where we use this. A particle moves in a straight line so its velocity v in meters per second at time t in seconds is given by v equals t squared minus 4t. Find an expression for its acceleration at time t. So we've got v equals t squared minus 4t. So acceleration is the derivative of v. So we're going to differentiate this. So it's going to be 2t minus 4, and that will be in meters per second squared. Remember to give the units. Let's look at another one. A car moves in a straight line so its velocity v at t seconds is v equals 5t squared minus t cubed for t between 0 and 4 seconds. Find v at 2 seconds. So here's our velocity, and the acceleration is the derivative of velocity, so that's going to be 2 times 5 is 10, t minus 3, t squared. So when t equals 2, acceleration is going to be 10 times 2 minus 3 times 2 squared, which will be 20 minus, that's going to be 4. 4 times 3 is 12, it's going to be minus 12, so that will be 8 meters per second squared. And one final example, something a bit more challenging. A particle moves in a straight line. So its displacement s meters at t seconds, where t is between 0 and 10, is given by s equals 1/3 t cubed minus 6t squared plus 15t. Sketch the shape of the velocity time graph and hence find the maximum speed of the particle. So we want to find the velocity time graph. So if s is 1/3 t cubed minus 6t squared plus 15t, the velocity is ds by dt. So we'll find the derivative. So 3 times 1/3 is going to be 1, so it's going to be t squared minus 12t plus 15. And that's in, so let's draw a little sketch of this. So when t is 0, it's going to be 15. We'll start up at 15. When t is 10, so down over here, it's going to be round about here somewhere. So it's going to come down and slope. Slope, something like that. That roughly kind of shape. You can check with graphing software when you have something like this to get a gist of what we're doing. Now, find the maximum speed of the particle. So we want to find when the acceleration is 0. So let's find dv by dt. So we're going to take derivative of this. So it's going to be acceleration. So 2t minus 12. And when that's 0 is going to be the turning point of the velocity time graph. So when a equals 0, 12t minus 12, oh, I think it's going to be 12, it's going to be 2. That equals 0, so equals 12, so t equals 6 seconds. Okay, so at t equals 6, the velocity, so we go back to what we have for our velocity up here. Velocity is t squared minus 12t plus 15. So it'll be 36 minus 72 plus 15, plus 16, 15, and that'll give us minus 21. Now, we want to find the maximum speed. So let's look at the shape of our graph. The velocity, this is our velocity curve, starts at t0 with a velocity of 15. So speed is the magnitude of velocity. So the speed at the beginning is 15. At the turning point, although the turning point is a minimum and the velocity is negative, remember the negative velocity is directional. So here is the 6 seconds. At this turning point, at t equals 6 seconds, the speed is the magnitude of the velocity, which is going to be 12 meters per second. Here at at t equals 10, the velocity is going to be minus 5 if you plug all the numbers in, meters per second. So the speed here would be 5 meters per second. So the maximum speed, therefore the maximum speed that the particle gets to is 12 meters per second, and that's at time equals 6 seconds. So when you're doing these and you're thinking about, so you've got your velocity timed graph and you want to know what, if for looking for the maximum speed that it's going to get, look at your so here we looked at the limits of the time, and we looked at the turning points, and we with the turning points is when the acceleration would be 0, and then you get the time, and you can find out the velocity at those times, and you compare them, remembering that velocity is a vector quantity and speed is a scalar quantity. So I hope that makes sense.